All right, as promised, I'm going to go ahead and I'm going to continue my notes for definition of a derivative, give you a couple of example problems, and move on from there. So we've already seen this example problem here. F of x is equal to x squared minus 3x plus 1. I believe I got through that with every class, where we got a function with respect to x. Underneath, I'll kind of talk about this a little bit more in detail tomorrow. So just be aware of that. And so when we flip the page over, we get a question that looks like this. We need to find f prime of x for f of x is equal to the square root of x. So let's start with that. Remember definition of derivative on the other side of the paper that you have. So I'm going to write it up here. Limit as h approaches 0 of the f of x plus h minus the f of x all divided by h. So I really need two things. I need f of x, which I have, and I need f of x plus h. And all that happens here is that x is now replaced with, I guess I don't need a parenthesis there, x plus h. And with that, I am able to go ahead and set up my problem. Limit as h approaches 0, the square root of x plus h, my f of x plus h, minus my f of x, square root of x, all divided by h. So my goal is to try to make sure that any constants wind up factoring out so that the only terms left are terms with h's, so that when I do this limit, I do not have to deal with losing terms or anything like that. So this problem is a problem where we're going to have to use our conjugate, x plus h plus square root of x over the square root of x plus h plus square root of x, essentially multiplying this by 1, not changing any functions. So this gives me the limit as h approaches 0. Square root of x plus h times square root of x plus h is x plus h. Square root of x plus h times the square root of x is square root of x plus h. Negative of the same thing, so those will cancel. Minus x over, and I'm going to leave this as just h times what I multiplied by. You should hopefully notice at this point the x here and the x here will zero out. And when I do that, I'm left with limit as h goes to 0 of h over h times the square root of x plus h minus square root of x, or plus the square root of x, my apologies, make sure I copy that correct. The h's reduced to 1. Now I've got the limit as h goes to 0 of 1 over the square root of x plus h plus the square root of x. There's nothing else that simplifies, and when the h goes to 0, you get 1 over the root x plus the root x, or 1 over 2 root x's. This right here is your f prime of x, which is one of the many ways that we are going to write a derivative, f prime, as we go through that. Now we're not done with the question. That was just find f prime of x. Second point is write the equation of a tangent line to the graph of f at the point 1, 1. All right, so now we need to write a tangent line. So let's talk about tangent lines. Tangent lines require two things. A tangent line is going to share a point, and it's going to have a slope. So to find the point, we know that the x value is 1, y value is 1. We have the point. It's going to be 1, 1. That was cool. That was easy. They gave it to us. Not always going to be the case. Be aware of that. And for the slope, what I'm really looking for is I'm really trying to figure out when is the derivative, what is the derivative when x is equal to 1. So I'm going to sub in a 1 here. 1 over 2 square roots of 1 to get 1/2. Which means we're ready to go. We are done with all of the work we need because we can now write it in point slope form. Y minus 1 equals the slope 1/2 times x minus the x value from the point. Remember, we do not simplify. We do not do any extra work beyond that. We are thoroughly done with the question. We do not put it in slope-intercept. We could move the plus 1. In a free response situation, we're stuck right there. So we're done. That's it. Pretty cool. All right. Let's take a look at another one. Ooh. Why is that right there? I don't know. We'll deal with that. So the second question, find f prime of x for f of x is equal to x squared. Same exact question. We've got a point. Let's go ahead and figure this out. So if f of x is x squared plus x, we need to find f of x plus h. All that means is x's are now replaced with x plus h's. So now we've got all of that, and we can set up my problem. My f prime of x is going to equal my limit as h approaches 0 and give me one. So limit as h approaches 0, and we do the f of x plus h, which we've already written down. X plus h squared, oh, make sure that squared's on the outside, plus x plus h. Now, I'm going to do something here in just a minute. Minus, oh crud, x squared plus x. You can see where this starts getting really confusing if you're not sure if you put the right thing in. So one of the things that I will do on a regular basis is I will use these brackets so that I know which one is f of x and which one is f of x plus h. Separates that out a little bit. This is not looking particularly pretty. The only work it looks like I can do is I can multiply out that binomial, get x squared plus 2xh plus h squared. I'm going to have a plus x and a plus h attached there. Wow. I'm going to get a minus x squared plus x, minus x squared minus x. One more. Don't forget to distribute the negative. All over h. The hardest part to this is that there's a whole bunch of algebra. We're looking for things to cancel. We're looking for all sorts of stuff. So I'm looking, I see an x squared, I'll do it in red. I see an x squared minus an x squared. I see an x minus an x. Everything else should have an h. So I look at what's left. 2xh, h squared plus h. That is looking beautiful. It looks like there's even an h I can factor out. So let's do that. Limit as h approaches 0. I'm going to factor out the h, leaving me with 2x plus h plus 1 all over h. Those reduce to 1, and we can go ahead and we can calculate out that limit. When h turns into a 0, you're left with a 2x plus 0 plus 1, leaving me with 2x plus 1. F prime of x. Kind of organize this a slightly different way. There is your first part. Second part, equation of a tangent line. What point is that? So for a tangent line, we need a point. I have it, 2, 6. I need a slope, which by definition, the slope of a tangent line is a derivative. So I pick f prime of x is equal to, not f prime of x, but in this case, f prime of 2 is equal to, let's see, 2 times 2 plus 1, which is now 5. And now we simply sub it in to the point slope form, and you are finished. Last question I want to look at then is question number 4 here. Skip over number 3. That's just like number 2. And I want to jump over to number 4. It says find dy dx for y is equal to 4 over x. Now, the only difference between f prime of x and dy dx is its notation. They both are representing the same exact thing. They both can be used slightly differently, so that's going to be an important thing here. Actually, it's not going to be important here. Dy dx is really just going to be the derivative still. And later on, we'll see that sometimes when we interchange the different methods, they'll help us out some. So, find dy dx for y is equal to 4 over x. Well, we still have to find the x plus h. So that would be what? 4 over x plus h. So we're going to do the same exact stuff we've been doing. Dy dx is still my limit as h approaches 0. Now, one thing I do want to point out, please don't get used to the fact that h is always going to 0. That is not the definition of the derivative. Remember what h represents. It represents the distance between x2 and x1. And I do not want you to fall into the trap of thinking that it's always the denominator, take the denominator to 0. Rather, It's whatever makes the equation in the denominator 0. That's going to go back to that alternative definition of the derivative that I was talking about. So the f of x plus h is 4 over x plus h minus 4 over x times h. Now you'll notice that when we did the limits thing, we basically did one of three different things. We multiplied things out, factored. No, we did some factoring. We did some multiplying things out. We multiplied by a conjugate, which we saw earlier in question number 1. And now if you notice, this question looks a lot like the get a common denominator question. That was totally on purpose, folks. All of those questions you did, you have been solving for derivatives since day 1, just without me using the name. So our common denominator in this problem is going to be x times x plus h. And for people who are still struggling with that, go ahead and just write out all the steps. So the common denominator, to make this x times x plus h, we'd have to multiply this by x over x. So you notice the x down here. This becomes 4x. If we factor out this x and we go ahead and we eliminate that, we go back to the original equation we had. Over here, to turn x into x times x plus h, I'd have to multiply this as 4 times x plus h. And you'll notice if I cross off the x plus h's, we're left with 4 over x, just like the original problem. Now this is gross. I don't like this, so I want to make sure that it's a little bit easier to look at. So I'm going to combine this as a single point here, x times x plus h. 4x is going to go right here, minus 4x plus 4h. So what I did here is I went ahead and I distributed the 4, and then I have the negative sign right there. And that over h here, I'm going to just turn it into a times 1 over h, because dividing by h is the same thing as multiplying by its reciprocal. Oh boy, this is getting to be a nasty looking problem. Let's keep going. We got 4x minus 4h over x times x plus h times h. The 4x minus 4x, and then I got an h divided by, oops, actually let's not do that yet. So then that gives me the limit as h approaches 0. And clearly I'm showing a lot of steps here. That's on purpose, folks. This is not necessarily the work you need to show, but all the work you need to show. I could actually go straight from here down to here, and I could probably go from here straight into this, or even the next step of this, the limit as h goes to 0, and those h's will reduce down to 1, leaving me with negative 4 over x times x plus h. All right, we're almost there, I promise. So the negative 4, that's not going to be affected. I can actually solve this limit because I'm not going to get 0 over 0 anymore. When the h goes to 0, I'm given negative 4 over x times x plus 0. So x times x plus 0 is just x squared. I get negative 4 over x squared, and that is my f prime of x. Now we got a slightly different setup here. So let's talk about the tan line. Tan function, tan line. I got this. Yeah, all right. So we got the tan line. I need a point, and I need a, oh darn it, and a slope. One thing I am kind of sad about is that this particular example actually gave you the full point. That's not always going to be the case. Oftentimes they will tell you that they want you to find something at x equals a value. And in that case, if you happen to notice, if I substitute in a 3 into my y function, okay, if I take y, and I'm going to use a weird symbol here, this is an evaluate symbol, x when x is 3. So this is saying, take the equation y and plug in an x equals 3 for it. If I did that, I would have actually gotten 4/3, which is what you can see they gave me. So that's just to show you that sometimes they'll make you do that. Not always. You don't have to show that if they gave it to you. And then for my slope, I need to evaluate dy dx. I need to evaluate that when the x is 3. Notice I used this different notation. This isn't a parenthesis situation like function notation. That is negative 4 over 3 squared, or negative 4/9. And just like any other one of these problems, y minus 4/3 equals negative 4/9, x minus 3. QED. We are finished. Ladies and gentlemen, that is all I have for you today. I will try to get this up. I apologize for the tardiness of this video. Come with questions. Come ready to work. And tomorrow you're going to get the opportunity to explore and actually utilize the definition of the derivative in class. Thank you very much for your time and have a wonderful day.